Hello everyone, welcome back to my channel Cat Voyager. This is Mayanka Chattopadhyay and today I am back with another video on algebra, specifically quadratic equation. The question on your screen is a previous year question from CAT 23 slot 1 paper, and the problem is related to quadratic equation. Okay, so before proceeding to solve the actual question paper, let us understand a few basic things about quadratic equation. So a general quadratic equation can be written in the form of a x square plus bx plus c. So what is a quadratic equation? Basically it is a polynomial where the highest power of x is 2, as you can see here, right? And it may or may not have, but maximum it has 2 roots. Let we denote them by alpha and beta. What is root? Root is basically the value of x at which this value becomes 0. Okay, so we can also write this equation in the form of x minus alpha into x minus beta equal to 0. Notice that if you put the value of x as either alpha or beta, this particular expression takes the value 0, right? So if we break this open, this becomes your x square minus alpha plus beta into x plus alpha beta equal to 0. Let we denote this as 2 and this one as 1. Okay, now if we compare 1 and 2, we will have that for 1 we had what, x square plus bx plus c equal to 0. If we divide both side by a, it becomes x square plus b by ax plus c by a equal to 0. Now we can compare this one and this one. How? Because the coefficient of x square in both the case is 1 basically. So we shall compare coefficient by coefficient. The coefficient of x here is b by a. So b by a is your, here it is minus alpha plus beta. And the constant terms are also should be equal. So c by a from here is equal to your alpha beta. Or from here you can write alpha plus beta equal to minus b by a. These things you have to remember will be useful in most of the questions related to quadratic equation. This is nothing but your sum of the roots, and this is your product of the roots, and they are given by minus b by a and c by a respectively. Okay, now let us also see how do we derive the value of x or the root of x from a equation given in this form. So let we have this one. This can be written as, if we take a common, that this becomes let's try to express it as a whole square term. So we have x square here, plus for this term we will have 2 into x into, to balance this thing we will write b by 2a, then we will have b by 2a whole square. Up till this we have a whole square term, but we don't have this term present in this here, so we will have to subtract this one. It will be minus b square by 4a square, and then we will have plus c by a as it is. Okay, now if this is equal to 0, we will have what, x plus b by 2a whole square plus c by a minus b square by 4a square equal to 0. A we have divided from both the sides. So if we take this one this side, it will become x plus b by 2a whole square equal to b square by 4a square minus c by a. Let us take square root on both sides. It will be x plus b by 2a equal to plus minus root over b square minus b square by 4a square minus c by a, or x equal to minus b by 2a, this comes on this side, and your plus minus root over b square by 4a square minus c by a. This can be further simplified. This is 4a square and here it is b square minus 4ac, or minus b minus b plus minus root over b square minus 4ac by 2a. A very common form. This is the root, general form of the root of a quadratic equation. And this thing, this b square minus 4ac is known as your discriminant, given by d. D is your b square minus 4ac, and depending of the value of this one, you will have the type of roots in the quadratic equation. So we have this b square minus 4ac within a root term, and if this thing is greater than 0, if b square minus 4ac is greater than 0, we will have two different roots, right? Because then it will give some finite value, can be given by k. So the roots will be minus b plus k by 2a and minus b minus k by 2a, two different roots. If b square minus 4ac equal to 0, this term vanishes, this term vanishes. So you will have only one root, a repeated root. The root will be minus b by 2a. And when your b square minus 4ac is less than 0, that means within the square root term we have a negative number, then the value of the roots become, the nature of the roots become imaginary. Okay. Also a thing to remember from here is that at x equal to minus b by 2a, we will have the maximum or the minimum value of a quadratic equation depending on the value of a. If your a is positive, you will have a unique minimum value of the quadratic equation, and if a is less than 0, then you will have a unique maximum value of your quadratic equation. Now let's look at how quadratic equations look like in xy plane. So if this is your xy plane, a quadratic equation will look something like this, or it may look like this. In this case, your a is greater than 0, and in this case your a is less than 0. These two are your roots, because notice, let's denote this as alpha, this is beta. Notice that alpha and beta, this value of the function is 0, right? The value of the graph is 0 at this point, also 0 at this point, and similarly for this case also. This is alpha, this is beta, these are the roots. And this value, this particular value of x is your x equal to minus b by 2a. Same here for this value of x. At this value x will be minus b by 2a. Now let's come back to our original problem. This we just discussed a few of the basics of quadratic equation. Let's come back to the original problem, right? So we had x cube plus 2r plus 1 x square plus 4r minus 1 x plus 2 is equal to 0, and they have said that it has minus 2 as one of your roots. Okay, so notice that the coefficient of x is 1, x cube is 1 here, right? So we can think of an alternate form of this expression as x minus alpha, x minus beta, and your x plus 2. Alpha, beta and minus 2 from here are basically the roots of your equation. Why 3 roots? Because the maximum power of x is 3 here. Minus 2 is already a root they have mentioned. So we will try to express this part in the form of this one. Okay, so let's try to take out the x plus 2 factor if possible. So first we have x cube. Then to get something in this form, x plus 2, we will need a 2x square. Why? Because we will take x square common from both this one and this one, and we will get a x plus 2. Okay, now we already have the coefficient of x square is this one, right? To balance, we are already taking this one, and to balance the coefficient of x square we need 2r minus 1 x square. Why? Because let's break this thing open. This is your 2r x square minus x square, and from here you have plus 2x square. So this 2 becomes your 2r x square plus x square, and if you take x square common, this becomes 2r plus 1, right? You have this one back. Okay, so yeah, this is done. Up till this is done. And then again, to have the x plus 2 here, we will need 2 into 2r minus 1 into x. Let's see why. From this 2, if you take 2r minus 1 into x common, this becomes x, and from here you will have 2, right? So this thing is also balanced. And next we will have what? X. Why? Because the coefficient of x in the original equation was this 4r minus 1 into x, and to counterbalance the coefficient of x we will add extra x here. Why? Because let's see, from here we have 4r. If we break this open, 4r x minus 2x plus your this x will give you 4r x minus x, or x into 4r minus 1. See, this one matches, right? So that's the reason. And then we will have 2 as it is. So this is your 0. Okay, now start taking x plus 2 common from this whole thing. It will give you x square goes common from here. This is your x plus 2. Then you will have 2r minus 1 into x common, and that will give you x plus 2. Next you will have already x plus 2, right? This is 0. So you have what? X plus 2 goes common from all the three parts. This is x square plus 2r minus 1 into x plus 1, this is your 0. Okay, so now this part of the expression is a quadratic in quadratic form, right? Now the question has said that the other two roots are real. Where are the other two roots present? The other two roots are present in this part of the equation and they are real. Now to be real, let's try to express this function, this part of the equation as we had seen earlier. What we said that if ax square plus bx plus c is your quadratic equation, then your roots become minus b plus minus root b square minus 4ac by 2a, and on the nature of this b square minus 4ac depends the nature of your roots, if the roots will become real or imaginary. Here they have said that the roots are real. That means this b square minus 4ac should be greater than equal to 0. So take that condition, b square minus 4ac greater than equals to 0. What is your b? Your b is nothing but the coefficient of x, which is 2r minus 1. So 2r minus 1 whole square minus, what is a and c? Your a is coefficient of x square, which is 1 here. Your c is the constant term, which is also 1 here. So this is your equal to 0, right? That means 2r minus 1 whole square greater than equal to 4. 4 goes on this side. This will give you 2r minus 1 either greater than or equal to 2 or 2r minus 1 less than or equal to minus 2, right? We have taken square root on both the sides. Okay, now they have mentioned that the minimum possible non-negative integer value of r. So this, we are not concerned with this part of the inequality. We will take this part and we will have what? 2r minus 1 is greater than equal to 2 or 2r greater than equal to 3 or your r will be greater than equal to 1.5. okay, and they have asked for the minimum possible non-negative integer value. This is not an integer. The immediate next integer bigger than 1.5 is 2. So the minimum value integer, non-negative integer value of r for this question is 2. That is your answer. So in this video we have seen some basic concepts regarding quadratic equations, and we have solved a question from the last year CAT slot 1 paper. Hope you liked and enjoyed the video. Hope some of the basic concepts you have understood. Very end of this video you will find a playlist containing all the previous videos I have made so far. They contain good problems. If you have not watched them already, I would suggest go back and watch them. And also please let me know in the comment section or reach out to me if you want me to make videos on any specific area of quant or DILR for that matter. Please let me know. Again, hope you enjoyed the video, and if you enjoyed, please don't forget to like, share and subscribe. And I will be back tomorrow with another such video. Thank you. Bye bye.